here we have a function f of x, x cubed minus 12x plus 16. And you're to factor this and sketch the graph. The problem is that we've never learned how to factor a cubic polynomial. We only learned how to factor a quadratic polynomial. However, the savior here is the factor theorem. I discussed this yesterday, right? What's the factor theorem? I might ask.
If multiple things multiplied together equals 0, one of them has to be 0.
Oh, no, that's the factor property. Yeah, okay. The factor theorem is that if fx is a polynomial, then and f, you plug in some number it's equal to 0, then fx has, oh, let's not even write f of x. Then x minus n is a factor. And being a factor means it's like you can express the original function as a product of this times something else. That's what being a factor means. Is that okay? All right. So that's the one that we are going to use. And the way we are going to use it is by brute forcing. Just plug in some numbers and see if you get 0, so that I can apply the factor theorem. So you can plug in -2. Let's see, what does -2 do? It's -8 plus 24 plus 16. So you get 32. Let's also try -1. Gives you -1 plus 12 plus 16. You get 27. F of 0, of course, is not 0, but this is still meaningful because this is your y-intercept. Because if f of 0 is 16, that means 0, 16 is a point on the graph, right? And then f of 1 is 1 minus 12 plus 16. 16 minus 12 is 4. 4 plus 1 is 5. And then f of 2 is 8 minus 24 plus 16. Oh, 8 plus 16 is 24. 24 minus 24 is indeed 0. Bingo. We have a 0. Okay? So if you have a 0, what do you do afterwards? You apply the factor theorem. What does it tell you? That x, what? What's a factor of this function? X what? Somebody says the correct answer. Say it again. X minus 2. Thank you. Yeah. It's x minus 2. Yeah. Since you plug in 2 and you get 0, that means x minus 2 is a factor. Okay. In other words, this thing right here is x minus 2 times something. Well, that still doesn't mean that we've figured out how to factor, because I don't know what this something is. So how are we going to get this other one? To do that, what we need is long division, okay? So what I need to do is I have to divide this x cubed minus 12x plus 16 by x minus 2. That's what I have to do.
So you're not using a guess and check. Oh, no, you guess and check first, and then you roll it.
Yeah, you just make guesses and see which one gives you 0. And if you get a 0, then bingo, you have x minus that number as a factor. But then to find the other part, you have to do the long division. Okay. So yes. Oh yeah. You can also do synthetic division if you know how. I don't have time to cover that today, but if you can teach yourself synthetic division on your own time, that's actually a much faster way to do it. Okay. Yeah. Yeah. If you know how to do synthetic division, you can use it. Yeah. All right, but let's just review the regular division. Say if you had something like 139 and you're trying to divide that by 7. How do you do this division? You first see how many times 7 goes into 1, nothing. 7 goes into 13 1 times, right? So you do this minus, what does that give you? That gives you, 6, and then 69, and then 7 times 9 gives you 63. Subtract, you get 6, right? That's how you do a regular division, right? And you say the end result is that 139 is same thing as 7 times 19 plus 6. And we have names for this. This one, this 19 is called a quotient. And this one here is called the remainder. Okay, so long division is basically the same thing inspired by the regular division, except that it has just two small differences. And the two small differences are, first of all, if you see something that's not there, so look, this is constant term. Constant is like x to the 0th power because anything to the 0th power is 1. Okay, so constant term can be thought as x to the 0th power. This is x to the 1st power. The x squared part is missing, right? It doesn't have any x squared term, but then you have x cubed term. Okay, so if you see a term whose power is missing, then you have to write this as 0x squared. Okay. Put a 0 there. That's one difference. Okay, you have to make sure that the missing x2 power has to be accounted for by putting a 0 there. So that's the first difference. And the second difference is over here, whenever we were choosing this number, we were trying to think about 1 times how many would be just under the 13 or just under 69 and so on, right? Here, instead of doing that, what we do is we just try to match the leading term. So the question is, the way we think is, what should I multiply to this so that this portion will be exactly x cubed? So what we want is we need to match the leading term. Okay. All right. So what do you think you should multiply to x to get x cubed? What times x gives you x cubed? X squared, yes. So you put here x squared, and x squared now gets multiplied to x to create x cubed as we wanted. But then because you're multiplying x squared to both of them, you still have to compute negative 2 times x squared, which is negative 2x squared, right? Now what should we do? Take a hint from here. What did we do here? Subtracted, right? So we should subtract here. X cubed minus x cubed cancel, so you don't have anything. What's 0 minus negative 2? No, 0 minus negative 2. Plus 2. Yeah, 2x squared. And then just like how after you subtract, this just comes down, right? You do the same thing. This just comes down. It's negative 12x plus 16. Why is it 2?
Negative minus negative.
Yeah, negative is plus, right? If you subtract a minus, that's same as plus. Okay. All right. Now, what times x gives you 2x squared? 2x, right? So we put plus 2x, okay? And then 2x times x is 2x squared. 2x times negative 2 is negative 4x. Subtract. And that gives you negative 8x plus 16. And then finally, for x to become negative 8x, you have to multiply by negative 8. So negative 8 times x is negative 8x. Negative 8 times negative 2 is plus 16. And when you subtract, you get 0. Okay. And 0 is indeed what we expected, because if you try to write the result of the division just in this format. Yes, you have a question? Which one's for?
Because aren't you supposed to divide the negative 8?
No, you're always multiplying, right? Yeah, you multiply. So 9 times 7 gave you 63. So in the same manner, negative 8 gets multiplied to negative 2 to give you positive 16, right? Yeah, in fact, if you ever get confused with the long division, it's a nice thing to do to stop for a moment and do a regular division. Hopefully you still know this. Yeah? You guys remember the regular division? Right? So you can do this and get some hints from there, because most of them are similar. The only difference is the way you choose these things, which is just to match the leading term. And then you have to put a 0 for any missing. So those are the only two differences between a regular division and a long division. Right? Okay, so now if I apply that format, what we just found out was that this is equal to x minus 2 times what? Times x squared plus 2x minus 8. And then plus, what's the remainder? 0. Yeah. So we really didn't have to write that plus 0. Okay. Now, we knew that it should be 0 because by the factor theorem, x minus 2 is a factor. Is that good? Being a factor means that if you divide, you don't have a remainder. That's what it means. But it's not done. It's not over, because we still can take this and factor further. So here we have so far that x cubed minus 12x plus 16 is equal to x minus 2 times x squared plus 2x minus 8. And I notice that this can be factored as well. How does that one factor? Can you find two numbers that multiply to negative 8 and add to 2? What are those two numbers? Yes? Yes, negative 2 and positive 4. So you get x minus 2. This is going to factor as x minus 2 times x plus 4. That's what you have. Now, being able to factor immediately allows you to know what the zeros of this polynomial is. So this polynomial has zeros at where? When is this equal to 0? X equals to 2. When is this one equal to 0? Negative 4. Well, it's the same thing, so both of them will have x equals to 2. Okay. Because x equals to 2 is repeated twice, we're going to say this one has multiplicity 2. This concept will be important later. Okay, now let's try. Yes, you have a question?
Is that when the graph goes back and touches it again?
Yeah, I'm going to talk about that later, right? Okay, so now let's try to draw the graph. The graph has a 0 at 2 and negative 4. So let's say here's 1, 2, and then 1, 2, 3, and 4, negative 4. So these are the zeros. And by the way, you probably noticed that for polynomials, zeros of polynomials really means the same thing as x-intercepts. Okay, so zeros is just another way to say x-intercepts. And to add to the confusion, there's still another word for word that has the same meaning as zeros, which is its roots. So roots of a polynomial, zeros of a polynomial, x-intercepts of polynomial, these are synonyms for the same thing, right? Well, you might say x-intercepts are slightly different because that they are actual points. So you might want to say x-intercepts are like coordinates 0, 2, and no 2, 0 and negative 4, 0, rather than the numbers themselves. But it's safe to say that these three are all synonyms. Okay. So that's what we have. And then we also have 16 as the y-intercept, right? 16 is the y-intercept. But it also goes up till 32, so it goes quite high. So rather than trying to make a really elongated graph, let's just say this much is 16 and this is like 32. Okay, so that we don't have to suffer trying to draw something that's too huge. So here's what we know. At negative 4 and 2, it gives you 0. If you plug in negative 2, it gives you 32. That's what this says, right? Negative 2, 32. And then if you plug in negative 1, what does that give you? It says so right there. Read it. 27, yes. So 27 is like a bit closer to 32, so it's more like here. And it's going to pass through here. It's going to pass through here. So it's going to pass through these points. Right. Now, that's not going to be enough for you to really draw the curve. So let's agree that we know the following fact. That, let's see, I'll just erase this one. So here are some facts. If you have a cubic polynomial y equals to ax cubed plus bx squared plus cx plus d, then the graph will look like this if a is positive, and it's going to look like this if a is negative. Now, however, it could be that this is somewhat less pronounced than this. Going up and down is less pronounced, and you might have something like this. So in this case, the graph continues to increase, except that the pace of increment somewhat slows down a little bit, but it still increases. So that's also possible. In this case, you could also have something like this as well. Okay. So those are the possible shapes of a cubic. And in our case, it's this case because x cubed has 1 as the coefficient and 1 is positive, right? So you have this. So we're going to draw this graph passing through everything. So it must be something like this, right? Now, what might help a little bit is if you plug in 3, and it's easier to plug in 3 here rather than to the original one. What's 3 minus 2? 1. 3 minus 2 is 1. 3 plus 4, 7. So at 3, you get something like 7, something here. At 1, we have something slightly smaller, as 5. So once you have this, now you can connect these and say it's probably something like that, right? That seems to be the graph. Okay, so that's the graph of this function. Okay. Is that fine? I just tried to draw this curve to go through all the points that I see. Now, one thing that you should know is that I drew it so that it looks like negative 2 is where it gives you the maximum. Is it true? Actually, it is true. Yeah, but usually it's hard to know these turning points. So this point is called a turning point. It's called a turning point because before this point it's increasing, after this point it's decreasing, right? So if at a point before and after it increases and decreases or decreases then increases, those are called turning points. So there's a turning point here and there's another turning point here, okay? And they happen to fall at -2 and 2, but usually it's very hard to figure out where the turning points are located at. And you actually have to get to calculus 1 to learn how to find the exact location of the turning points. At this level, we just draw it, and it might match to be on an integer, but it might be slightly off, and you never know what's going to happen. Okay, but so you don't have to draw a correct graph. It's something like this that you need to draw. Now, okay, try this one. See if you can factor. All right, solution. If you plug in 1, you see that this is 1 cubed plus 4 times 1 squared minus 5. That's just 0 because it's 1 plus 4 minus 5 equals 0. Now the factor theorem says, therefore, what's a factor? X minus 1 is a factor. So that's why you're going to divide x cubed plus 4x squared plus 0x minus 5. Okay? That's what you need to put. And then what should you multiply to x so that it matches with x cubed? X squared. So x squared times x gives you x cubed. X squared times -1 gives you minus x squared. Subtract. What is 4 minus -1? What? Yeah. 4 minus -1 is same as 4 plus 1. So it's 5x squared plus 0x minus 5. And then what times x gives you 5x squared? Plus 5x, right? So you put 5x here. 5x times x is 5x squared. 5x times -1 is negative 5x. Subtract. And that gives you nothing. And then 0 minus -5 is 0 plus 5. So you end up with 5x minus 5. And finally, you put plus 5 because 5 times x gives you 5x. But then 5 times -1 gives you -5. Subtract. What do you get? You get 0. Now, because the factor theorem says that this is a factor, if you did the division correctly, your remainder should be 0. If that's not 0, that means you made some mistake somewhere. Most likely, like something like thinking that 4 minus -1 is 3 or something. It's you have to make sure that minus minus becomes plus, so it's really 4 plus 1. That's how you get 5. All right, so now let's see what this means. This means that this polynomial is x minus 1 times x squared plus 5x minus 5. Now, unfortunately, you'll never, plus 5. Unfortunately, you'll never be able to find two numbers that multiply to 5 and add up to 5. So when you look for the zeros of this polynomial, when you set this equal to 0, you will see that x minus 1 has to equal to 0, which means x equals to 1. And this one, you can't factor, so what's another option if you can't factor? Either completing a square or quadratic. If it's even in the middle, then we would like to do the completing the square, but it's odd, so we'll just resort to the quadratic formula. So it's going to be -5 plus minus square root of 5 squared minus 4 times 1 times 5 over 2 times 1. So it'll be -5 plus minus square root of 25 minus 20, which is just 5, over 2. Okay. All right, so do you know the approximate value of square root of 5? It's about, you should know these values. If you're, it's handy if you know them, okay? So square root of 5 is about 2.2, okay? So 2.2 divided by 2 is like 1.1, so it's -5 over 2 plus or minus 1.1. Those are the zeros. So let's try to draw these. You have 1. And negative 5 over 2 is 2.5. So here's negative 3 and negative 2. Here's negative 2.5. And plus 1 and minus 1. So approximately, you're going to get a point somewhere here and here. Those will be the two zeros, approximate value, okay? You can also use your scientific calculator to just compute that and get some idea of where that point is. But now we have 3 points, right? Okay. In addition to this, what is the y-intercept? Negative 5, right? So negative 5 is, let's just say negative 5 is somewhere here. Okay. Usually these cubic graphs, they produce such a huge number, you want to squash them. So you don't want to scale the x and y in the same way. So we're going to scale so that this much is 5, although over here, 5 is all the way up here. Okay. All right, so with that, what do we have to draw now? Right? The cubic curve, that's like this, right? We draw, oh, has to pass through it. Yeah. So that's what it's going to be. Okay. Now, anything that looks like this would be full credit because you don't know calculus. But if you learned calculus, then you can do slightly better. You'll actually find that this point is the turning point. So it's more like this, and it turns and goes up. But it doesn't have to be that exact. Okay. All right. So that's the answer. Okay. So since you've seen 2 examples, sorry. Yeah.
We were all about to get that very wrong.
Okay. All right. Okay, so what I want you to do is you have to think about numbers that are factors of this. So those are what? 1, 2, 3, 6. You have so many. Yeah, but sometimes it kind of narrows down to a few choices. We definitely know that for example 5 wouldn't work, right? Because it's not a factor of 24. Yeah. Yeah. But you would, so if I would go about finding the value, I would start from 1, negative 1, and if it doesn't work, try 2, and then negative 2. At some point, if it can be factored, at some point you'll get 0. Okay. Also, although f of 2 is also 0, just try f of 3 equal to 0. So the factor theorem says if f of 3 is 0, what's a factor? X minus 3 is a factor, right? So what we are going to do is we are going to take negative 2x cubed plus 6x squared plus 8x minus 24 and divide this by x minus 3. Okay? So we are assuming that if you plug in 3 and do the calculation, you get 0. You can check, okay? So x minus 3 is a factor. Let's see. What times x gives you negative 2x cubed? Negative 2x squared, right? So you get negative 2x squared, x cubed. This time this is plus 6x squared. Subtract. You get 0 for everything. So now here comes 8x minus 24. That's the only thing. Oh, so now what must be multiplied to match the leading term? 8. So multiply by 8. 8 times x is 8x. 8 times negative 3 is negative 24. Subtract. What do you get? You get 0, right? Yeah, if you subtract the negative, it's plus. So negative 24 plus 24 is 0. Okay. All right, so you get that. And that means that negative 2x cubed plus 6x squared plus 8x minus 24, this thing that you're dividing by, is equal to x minus 3 times negative 2x squared plus 8. Okay. Now the question is, can you factor this one as well? And the answer is yes. And it's a bit technical because you see 2 and 8 are both divisible by 2. Do you agree? So you can factor 2 out. And while you're at it, why not factor the minus out as well? Because you can. So we're going to factor a negative 2 out. And the end result is negative 2 taken away from negative 2x squared would be just x squared. And then negative 2 times what gives you 8? Negative 2 times negative 4. This times this gives you negative 8, positive 8, right? So that's what you get. And if you do that, now you have to figure out how to factor x squared minus 4. That's difference of two squares, right? So what's the formula of a squared minus b squared? This is a minus b times a plus b, right? That's the way you factor. So x squared minus 4 is going to be x squared minus 2 squared. And applying this difference of two squares formula, it becomes x minus 2 times x plus 2. Now, if you didn't understand this, there's yet another way to say it. X squared minus 4 is x squared plus 0x minus 4. Isn't that right? What are the two numbers that multiply to negative 4 and add up to 0? What's that? 2 and negative 2. So you get the same factor if you view it this way. Okay? So either way, we see that it should be negative 2 times x minus 3 times x minus 2, x plus 2. Okay. Now tell me the zeros of this polynomial. What are the zeros? 3, 2, and then negative 2, right? These are the zeros of the polynomial. What's the y-intercept? If you plug in 0 to this, what do you get as the y-intercept? This one, negative 24. But as I said before, we're going to squash the y-axis. So instead of putting negative 24 all the way down here, let's just put negative 24 here. Okay. Now, is the shape of the cubic this way or this way? Which one? This one or this one? Which one? The second one. Why? Because the coefficient of x cubed is negative, right? So since the coefficient is negative, it must be this shape. So what we are going to do is we're going to draw a curve that looks like this, connecting these 4 points. Okay? So let's do that. Must be something like this. Okay? And I really don't know if the turning point is right after this point or exactly there or on the left side because I don't, we're not assuming calculus. But if you learn calculus, you can actually determine that as well. But this will be the best you can do for Math 90. Yes?
Not that you do this, but technically if you apply your points correctly,
Uh-huh.
close enough, you don't have to even look if it's negative or not because you could just tell. But
Right, you can just plot more points. If you plug in 1 or if you plug in negative 1 and plot more points, it kind of dictates that it has to be this shape rather than having to look at that. But you know that having that knowledge that negative coefficient should be this form is helpful because it reduces any errors. All right? Okay.